Hey guys, it's Andrew here again. In the last video, we did some classless subnetting. Again, we're getting into this classless range here. We're breaking away from that /24, that /16, and we are now going to subnet a /23 network, right? So I've given you this network 172.20.0.64, and we are going to /23, and we're going to go through and we're going to break this down, all right? So again, 23 is 23 ones in my subnet mask. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, not 8. All right. So 8, 16, and then 17, 18, 19, 20, 21, 22, 23, and then a 0, and then 1, 2, 3, 4, 5, 6, 7, 8. All right. So 255. 255. What's that? Well, it's not 255, right? It's 7 ones and then a 0. If we put this all out, this is the 1 bit, right? So just like -1 would be 254. Again, you guys can put that through the into your decimal chart, right, in your binary chart, and do out the math, and you'll find that it's 254.0. Okay? So, once again, NFLB, we solve for the network address. All right, so we're going to come here, and again, this is going to be, I'll do the binary this time again, just for good measure. 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, and then that's all zeros. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and that's all zeros too, even though this has got this one here, 1, 2, 3, 4, 5, 6, 7, 8. All right, so we can find that this is 172.20.0.0/23. All right, there's my network address. But once again, if I kind of draw the line like this, try to keep this one going again as straight as possible, right down the chart. There it is. I've got 9 host bits, 9 zeros, 9, count them, 9 host bits, and 23 network bits. Okay, so we can go through and we can now find the broadcast address. All right, so I'll hunker down here, and you can bring this all down here. So 1, 0, 1, 0, 1, 1, 0, 0, dot 0, 0, 0, 1, 0, 1, 0, 0, 4 zeros, 1, 2, 3, 5. I'm sorry, all zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, right? And then there's 8, okay? And then 1, oh, sorry, got ahead of myself. Oh, remember, I almost forgot, we flip them, right? This is the broadcast. So we flip the bits. Okay. So that's 1, 2, 3, 4, 5, 6, 7 network bits. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8 host bits, right? So we take the host bits and we flip them. All right. So what does this look like in binary? You know, what do we do? Remember that even though I flipped the host bits, I still solve my my binary values into decimal based on the entire octet of each one, okay? So this is still 172, this is still 20, but this, 7 zeros, 1, 2, 3, 4, 5, 6, 7, and then a 1 is 1, 255, all right? So my broadcast address here is 172.20.1.255, giving my first address 172.20.+1, and my last 172, like so, cheat a little bit, 21.254. Okay? So that's my entire range. Okay? So how the heck does that work, right? Again, I kind of touched on this in a previous video, but again, if we have host bits, 9 host bits, right? 2 to the 9th, that's 512. All right? Dang, that's a lot, right? Minus 2, we have 510 total hosts that could exist in this network, right? Now, carefully look at this. This guy right here can go 1 to 255. So now 255, 172.20.0.255 is an actual address. It's not a broadcast address. This is the broadcast address down here. All right, that guy's the broadcast address down there. Okay, so remember, like I said, we start with 172.20.0.1, right? And then we go up to 172.20.1.254, right? And, you know, so, I mean, in this case, 0.255 is a valid address, but remember, each octet can only go up to 255. So how do I get more, right? How do I get more? Well, I get more by increasing the next octet over, right? So I've used up, right, 1 to 255. I need my what would be 256 or 257, right? It's actually 1.0 and 1.1, 1.2, all right? So again, it's a little bit of a jump, right, when you get into Class B networks. But we start increasing, so basically you use up this last octet, all right, 0, or so 1 in this case, of usable addresses, 1 to 255, and then when you need another address beyond 255, you don't go to 256, doesn't exist, all right, you go to 1.1.0, all right, and then 1.1, 2, 3, 4, all the way up to 1.254, all right? And that range, right, 1 all the way from here to here, including this shift from a 0 to 1, is going to give me that 510 usable addresses, all right? Some people might also look at this and go, well, a /23, right? We know a /24 has 256 total networks, or sorry, total hosts. /23 has 512, all right? Divide that, and you have 2 networks, 2 /24 networks, all right? Remember, a /24 network might be 172.20.0.1/24, right? And you can get a range anywhere between 1 and 254. But in this case, again, we could look at this, if it helps to conceptualize it, as 172.20.0 and then 1 to 255 as usable addresses. That would be like 1/24. And then the next one, that second one, would be this .1, or sorry, 20.1. All right. Again, it's a little bit of a stretch. But as you start to get a little more comfortable with working with this range here, we can actually extend back and forth and back and forth. And if I made this a /22, all right, that would have shifted this guy this way. This down here, right, that would have been a 1, right? And this range would have been down to up to 3, right? And that would have doubled a /22, all right, equals 2 raised to the 10th, which would be 1024, divided by my 256, or 4 Class C networks. All right. Just if you need help visualizing it, you know, some people look at it and say, well, a B class network, this somewhere between /16 and /23. A /23 is 2 Class C networks, is worth that much. And then a /22 is 4, right? And then if we go up more, it would be 8, and then 16, and so on and so forth. number of Class C networks that you could pack inside of a Class B. All right, if it helps to conceptualize it a little bit for you. All right, but ultimately, again, as we go this way with our networks, the real pattern here is we go this way and we give more host bits, right? We have more host bits, our networks get larger, and we have less networks. All right, so again, it's always a trade-off back and forth between how many hosts and how many network bits. And it's really going to come down to how much you need, right? So on the next set of videos here, we're really going to start breaking down our networks. So we're going to break down our networks into even sizes. And I'm going to stick with a Class C and smaller, so /24 and smaller, to keep the numbers small and make it a little bit easier to conceptualize. But we'll actually start to look at it and go, how do we break this down into smaller sub-pieces? And we kind of started to look at that with that /25, right? That /25 took our /24, and we had our 256, and we did 128 because our /25, we cut that in half, right? We've already kind of seen this, but now we're really going to apply it, all right? We're going to have a little problem here, and we're going to apply this, this subnetting feature. So I'll see you guys in the next video.